For the triangle below, find the cosine of 2 theta. Well, this particular triangle is known as an isosceles triangle because it has 2 legs that are the same length. If all 3 legs are the same length, then it's known as an equilateral triangle. But this is an isosceles triangle. And because you have these 2 sides being the same length, it is the case that this angle and this angle, that is the opposite angles, are also of the same measure. Now at this point we can drop a perpendicular bisector through that bottom leg, and that will look something like this. And now what we have done is we have established 2 identical right triangles. So we'll focus on the one on the left-hand side here. So we know what the length of the hypotenuse is. That is 10. We know that the length of this leg of that triangle is half of the length of this leg. So let's kind of label that in this fashion. It is 10 times the square root of 3 for that whole length right there, which means it is 5 times the square root of 3 for the length of that leg. Finally, if we let the height of this other leg be b, then the Pythagorean theorem tells us that 5 square root of 3 squared plus b squared is equal to 10 squared. If we solve that equation for b, we will get the length of this side of this particular right triangle. So first of all, what is 5 times the square root of 3 squared? 5 squared is 25. The square root of 3 squared is 3. 25 times 3 is 75. 10 squared is 100. If you subtract 75 from both sides of this equation, you'll get b squared is equal to 25. If you take the square root, you will get b is equal to 5. Now, we don't have to worry about the plus or minus in this case because this is a length. So we know that the value of b is equal to 5. And now let's take a look at, for example, the sine of theta. So if I want the sine of the angle theta, which is right here, you know from the definition of the sine that the sine is the length of the opposite side divided by the hypotenuse. So in this case, the opposite side is 5, and the hypotenuse is 10, so the sine of theta is 5/10. And 5/10 in lowest terms is 1/2. So now what we want to do is we want to figure out the measure of an angle that is somewhere between 0 and 90 degrees that has a sine of 1/2. Well, you remember in the winding function that the sine is the second component, and so having a sine of 1/2 puts us at this point right there. The coordinates of that point are the square root of 3 over 2 and 1/2. And that particular angle right there is pi over 6, or 30 degrees. So what we get at this point is the measure of this angle right here, that is a 30-degree angle. Finally, to come back and solve the problem, we want the cosine of 2 times theta, which is, we want the cosine of 2 times 30 degrees, which is the cosine of 60 degrees. Now, 60 degrees on the winding function is up here. And the cosine is the first component, and the first component for this point right here is 1/2. So 1/2 will be the solution to the problem.